Hi everyone, welcome to another lecture in ChemE 122, and this time we are going to be discussing our thermodynamic properties of real fluids. And for the first part of the thermodynamic properties of real fluids, we want to now establish the relationships between all the multiple thermodynamic states, multiple thermodynamic variables that we currently have. Kasi ngayon sobrang dami na ng relationships or thermodynamic variables na meron tayong temperature, pressure, volume. You also have entropy, enthalpy, internal energy, and so on. So now, mathematically, how do we relate each of these thermodynamic properties to one another? And how can we measure the change in one thermodynamic property in terms of other measurable quantities in a particular thermodynamic system? So ang goal natin is to understand the derivation of fundamental property correlations and to derive relationships between common thermodynamic properties and variables using these fundamental property relations. So for example, gusto natin, let's say, measure now change in enthalpy. How do we measure change in enthalpy with respect to, let's say, a change in pressure, temperature, and a change in pressure, or a change in entropy using a change in temperature and a change in pressure? Or even, how do we obtain a change in internal energy from change in entropy and change in enthalpy, maybe? Okay, so all of these thermodynamic variables, along with your volume, okay, and other measured properties can be related to one another. Okay, so just for a quick review, we define what we call our measured properties, which are your temperature, pressure, volume, and your composition. Okay? So in most thermodynamic systems, at least for 122, we will assume our systems are of fixed composition. Of changing compositions, these will be discussed next semester in ChemE 123. So for this lecture, temperature, pressure, and volume, yung mga gamitin natin na measured property. Okay, kasi in a lab, ito yung madaling i-measure from the name itself. Okay? And we define now our fundamental properties, which are derived from laws of nature. And the first law of thermodynamics, we have internal energy. And from the second law of thermodynamics, we have derived the property of entropy. And we also have what we call derived properties, which are a combination of fundamental properties and measured properties. So one derived property that we have is enthalpy. And enthalpy is conveniently defined for open systems, okay? Kasi meron tayong term for the internal energy and the flow work na PV. We also have another two derived properties, okay? Recall yung discussion natin on exergy, okay? So the maximum amount of work or the maximum useful work obtainable from a system. And we have the Gibbs free energy, which is defined as G is equal to H minus Ts. And this is the useful work obtainable from an open system at a constant temperature and pressure. Meanwhile, for a closed system, equivalent ng Gibbs free energy is the Helmholtz free energy, okay? Defined by the letter A, and A is equal to U minus Ts. And the Helmholtz free energy is the useful work obtainable from a closed system at constant temperature and volume. Okay. So now recall, we have said that internal energy and enthalpy, these are state functions along with entropy. So as long as you know the initial and final states, you know kung ano yung change in enthalpy, internal energy, and change in entropy as well. So as we can see, the Gibbs free energy is a combination of two state properties. Okay, combination ng enthalpy and entropy. Tapos ang Helmholtz free energy, combination ng U and internal energy and entropy. So meaning, if both G and A are combinations of state functions, therefore, they must be state functions themselves as well. So again, our goal here is to relate the fundamental and derived properties, okay, to quantities which are easily measurable in the lab, so pressure, temperature, and volume, or have reported data like our CP and CV, and based on the last week's discussion, we have beta and kappa. So itong mga fundamental properties ito, internal energy and entropy, and our derived thermodynamic properties, which are enthalpy, okay, Gibbs free energy, and Helmholtz free energy. I-relate natin yan ngayon to pressure, temperature, and volume, or to CP/CV, beta, and kappa for constant composition systems. Okay. So again, our discussion will be limited to constant composition systems. So wala muna tayo mga mixing. Okay? And To do this, we will now use mathematics to develop a web of various relationships between multiple combinations of thermodynamic properties. So all of these thermodynamic properties that we have are interconnected to one another. And how do we now derive the relationship between all of these thermodynamic properties to obtain useful relationships and we can now exploit? And now to start our discussion on the derivation of these thermodynamic property relationships, we have to recall Gibbs phase rule. And for Gibbs phase rule, it states that for a system of known composition, you only need two intensive variables to fully define all other intensive variables of your system. So you can obtain that from f is equal to 2 minus pi plus n. So if you fix the composition, kailangan mo lang ngayon ng dalawang intensive variable para malaman na lahat ng other intensive variables ng system natin. Or in other terms, if you want now to measure the change in that particular intensive variable, okay, let's say you want to measure the change in the intensive variable z, okay, you can now just measure the change of two other intensive variables. Let's call that x and y. So in mathematical terms, the change in any intensive thermodynamic property of interest z can be written in terms of the partial derivatives of two independent intensive variables, x and y. And this can be denoted by z of x and y. So meaning, okay, the change in the variable z, dz, is equal to, okay, the change of z with respect to x, or one variable, holding y constant, okay, dx, plus the change in z with respect to y at constant x, dy. So meron tayong two change terms, one with respect to x, holding y constant, and one with respect to y, holding x constant. Okay? And this now is an exact differential, and the integration of dz is now independent of the path. Okay? So medyo mag-math tayo ngayon dito. Okay, so first, to start our derivation, let's recall the first law of thermodynamics for a closed system. And recall that the first law of thermodynamics for a closed system, du, is equal to dq plus dw. Okay, so now how do we express the change in u with respect to other measurable quantities? Okay, so first recall, for mechanically reversible processes, we have an expression actually for dq and dw. And recall, okay, that the dq reversible is equal to the quantity TdS, and the reversible work is equal to negative PdV. Okay? And if you simplify this, so substitute dyan, okay, you can see that du is now equal to TdS minus PdV. Ngayon, we can see, okay, now our property u is now in terms of three measurable quantities na temperature, pressure, and volume. Okay, so you can now actually do this for other thermodynamic properties. Okay, so recall the definition of enthalpy, and H is equal to U plus PV. Okay, so let's say you want to get DH. Okay, so take the derivative. So magiging DH is equal to DU plus DPV, so chain rule. So plus PDV plus VdP. Okay, so ito, meron tayong dalawang quantity dito na pressure and volume. Now, internal energy, pwede natin siya palitan. Itong buong term na to, substitute. So this is equal to TdS minus PDV plus PDV plus VdP. And now, dH is equal to TdS, okay, plus VdP. Okay, and again, we have H, okay, our thermodynamic property, or derived property, which is now expressed in terms of the measurable quantities, temperature, pressure, and volume, as well as entropy. And you can actually still do this for the definition of G, okay, and the definition of the Helmholtz free energy. So para gawin yan, again, diba, G is equal to H minus Ts and A is equal to U minus Ts. So pwede mong i-substitute again si DH dito and si DU dito. And you can make the necessary substitutions. And if you do that for G and A as well, you can get the following four relationships. So DU, DH, DG, and DA okay, measured in terms of the changes with respect to entropy, volume, okay, temperature, and pressure. Ayan. Okay? And these equations are collectively known as your fundamental property relations. Kasi now the fundamental property relations kasi even when derived for reversible processes, the final expressions are solely functions of the properties of the actual system. Okay? Ano yung properties ito? Siyempre, temperature, pressure, and volume, as well as the measure of disorder or entropy of our system. Okay? Yan. And these expressions, whether applicable, whether reversible or not, okay, if the process is either reversible or irreversible, okay, these equations will still hold true kasi, di ba, U, H, G, and A, these are all state functions and therefore they only need to depend on the properties of the system, or rather, the initial and final properties of our system. Okay, ang magiging limitation natin is, if the process is irreversible, dq is not equal to TdS anymore, and dW is not equal to negative PdV anymore. However, the combination of TdS and PdV, na TdS minus PdV, will still hold true to give you your change in internal energy. Okay? So now, meron tayo actually dalawang ways to get the change in internal energy. So recall the fundamental property relation na du is equal to TdS minus PdV. Okay? However, you can also write this in terms of an exact differential na u as a function of s and v. And pansin natin, di ba, meron tayong ds term dito, meron tayong dv term. Okay? So there must be a quantity related to temperature and a quantity related to pressure as well. Okay? So recall, if you write USV, okay, you can get this following expression. So du is equal to the change of the internal energy with respect to entropy, holding V constant ds, plus the change of internal energy with respect to volume, holding entropy constant dV. Okay? And these two equations are analogous to one another. Okay? These equations are both mathematically true, meaning that the partial derivative of u with respect to s at constant v is now just equal to the temperature, and the partial derivative of u with respect to v holding s constant is also equal to negative p. Okay? Diba? Ito for fundamental property relations. So therefore, du over ds at constant v is equal to t, and du over dv at constant s is equal to negative p. Okay? And from this, okay, t and p are properties. Okay? We can call the quantity USV, so the combination of the internal energy, entropy, and volume form what we call a fundamental grouping. In fact, you can do the same derivations to obtain the other fundamental groupings for enthalpy, Gibbs free energy, and the Helmholtz free energy. Okay, so for internal energy, USV, ito yung fundamental groupings na meron tayo. Ayan. For enthalpy, HSP. For Helmholtz free energy, ATV. And for Gibbs free energy, GTP. Okay, so how to derive this, please practice this on your own. Okay, so next up naman for thermodynamic property relations, okay, is how do we actually can relate, okay, temperature, pressure, entropy, and volume with respect to one another. Okay, so in order to do that, recall again the definition of an exact differential. Okay, so itong term natin na, let's say, z xy, this is an exact differential. So meaning, you can write dz is equal to m dx plus n dy. Okay, and for an exact differential, this equation should hold true. So recall your ChemE 105 for this. So the partial of m with respect to y, holding x constant, is equal to the partial of n with respect to x, holding y constant. Okay, so now how do we use the definition of the exact differential for this? So recall again itong internal energy natin, which is the fundamental property relation TdS minus PdV. Okay, and you can also write USV. Okay, so du is equal to partial of u with respect to s at constant v ds plus partial of u with respect to v at constant s dv. Okay, And recall the definition of an exact differential, dz is equal to m dx plus n dy. Okay, meaning, if this is an exact differential, you have this whole term, partial of u with respect to s at constant v, this is m. The partial of u with respect to v at constant s, this is equal to n. Okay, so m, ito yung value niya, and n, ito yung value niya. Okay, so with this, you can now express, using the definition of the exact differential, okay, the partial of m with respect to y at constant x is equal to partial of n with respect to x at constant y. Okay, so if this is m and this is n, you can now plug it into this equation. Substitute yan. Tapos ito, substitute dito. Okay, and make the necessary substitutions, you can get the following equation. So the derivative of this whole variable, okay, with respect to v at constant s is equal to derivative of this whole variable with respect to s at constant v. Okay. However, recall na meron tayong term for du over ds at constant v, okay, from our fundamental grouping, and as well for du over dv at constant s from our fundamental grouping kasi, diba, usv, ito ay fundamental grouping. And yung fundamental grouping na yan is, okay, du over ds at constant v is equal to temperature, and du over dv at constant s is equal to negative pressure. Okay, and you can, these two are equivalent, so pwede mo i-substitute to ngayon dito, and ito, substitute mo ngayon dito. Meaning, the partial of t with respect to v at constant s is equal to the negative partial of p with respect to s at constant v. Okay. So you now have the relationship of temperature, pressure, volume, and entropy with respect to one another. Okay. So using the fundamental grouping for internal energy, you can derive this particular equation. Okay. And this particular relationship for T, V, S, and P. And you can also do the same for enthalpy, the fundamental grouping, okay, and the fundamental property relation, and the combination of G and A as well. Okay, so pagkasamahin natin dito yung exact differential definition, yung ating fundamental property relation, and ang ating fundamental grouping, like what we did just now, okay, for internal energy. And doing that, we derive what we call now our Maxwell's relations. So you now have four possible relationships between entropy, temperature, volume, and the pressure of a particular substance. Okay? And ang kagandahan with using Maxwell's relations is that this allows us the calculation of ds using PVT, which can then be used to calculate du, dh, dA, and dg. Kasi, diba, measurable quantity science sa lab is pressure, volume, and temperature. Hindi natin na-measure si actual entropy change. Okay? However, yung fundamental property relations natin, U, H, A, and G are given in terms of P, V, T, and S. Ngayon, para makuha yung change in S, kailangan siya i-relate in respect to pressure, volume, and temperature. In fact, the most useful in these Maxwell's relations, okay, itong mga derivations ang walang S. So for example, ds over dv at constant t is equal to dp over dt at constant v, and the same for this one. So makuha natin yung change in entropy or function of entropy as a function of the change of pressure, temperature, and volume only, which we can now exploit in deriving other relationships of higher thermodynamic properties, so like U, H, A, and G. Okay, so some other possible useful mathematical relations that you may need. So you have your chain rule. Okay, you can also have your derivative inversion, and you can also have your triple product rule. And these are used to manipulate other thermodynamic properties, okay, to obtain an equation that will be useful to us, or to prove another relationship between multiple thermodynamic properties and multiple thermodynamic variables. Okay, so typically, ito yung mga nangyayaring relations. Okay, so 'di ba meron tayong P, V, T, and S. So you can derive relations, okay, without the temperature term. You can also derive relations without the pressure term, without the volume term, or without the entropy term. Okay, so we can make use of this web of thermodynamic properties to derive more useful thermodynamic property relations, which all hold mathematically. Okay, so now, you may ask right now kung kailangan ba talaga i-memorize lahat ng mga fundamental property relations, lahat ng fundamental groupings, and lahat ng Maxwell's relations. Okay, kasi 'di ba, na-derive natin lahat 'yon. Okay, so you can memorize them if you want, although you don't need to memorize them. Or, there's actually a useful mnemonic for this, and this is known as the Guggenheim scheme. Okay, and it's a Guggenheim scheme, or I like to call it Chipugvat. Okay, so draw the thermodynamic square in this manner. And para gamitin to, okay, so meron tayong three ways to use this. One is for the fundamental property relation, okay, one is for the fundamental grouping, and one is for Maxwell's relations. Okay, so first, dito muna tayo sa fundamental property relations. So pansin natin, yung nasa four corners, ayan, okay, yung four corners na yan yung mga measurable quantities natin at entropy, okay? Tapos yung nasa apat na gitna, okay, yan yung ating mga fundamental property group, fundamental relations. Okay, so first, let's try to get an expression for du. Okay, so how do we use this to get du? Okay, so take note, yung mga naka-negative dito ay yung nasa top, so S and P. Okay, so first, to get du, okay, so yung katabi niya, S and V, so ito yung naka-derivative. So, write muna ds and dv. Okay? Tapos, directly, sa opposite corner ni S ay temperature. Okay? So, naka-D ito. Ayan. Tapos, directly opposite it, S ay temperature pero positive. So, TDS. Directly opposite V is negative P. So, minus PdV. Ayan. So, next, what if gusto mo natin enthalpy? So, dH is equal to ds, tapos dP. Opposite S is T. So, TDS. Opposite P is positive V, so plus VdP. Isa natin G. So, dG is equal to, okay, dP, tapos dt. Okay? Opposite T is negative S, so negative S dt. And opposite P is V, so plus VdP. And same for A. Okay, dA is equal to, meron tayong dt, meron tayong dV. Okay, opposite V is negative P dV. Opposite T is negative S, so negative S dt. So from here, you can now have your four fundamental property relations. So next up naman natin is our fundamental groupings. And for our fundamental groupings, papansin natin ngayon, the four corners here are actually the properties. Okay? Tapos, yung apat na nasa sides, okay, they are adjacent or right next to yung fundamental grouping nila. So, meron tayong one fundamental grouping here, 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 and here. Okay, so in order for you to get the fundamental groupings, okay, so let's start with yung isa sa gitna. So, let's say U. So, partial of U. Then, pili ka ngayon kung ano yung gusto mong denominator niya. So, isa sa denominator niya, let's say S. So, partial of S. Okay, tapos, syempre, yung kabila at constant V. Okay, so ngayon, kung ano yung nasa denominator, which is S, directly on the diagonal, yun yung equivalent niya. Okay, so partial of U with respect to S at constant V is equal to T. And the same way, partial of U with respect to V naman at constant S, okay, is equal to negative P. Similarly, pwede rin partial of H, okay, with respect to P at constant S, this is equal to, nasa diagonal, V. Okay? And partial of H with respect to S at constant P, this is equal to nasa diagonal ng S, which is positive T. And you can do the same for A and for G. And last but not least, how do we write Maxwell's relations using the Guggenheim scheme? Okay, so again, meron tayong apat na corners. Okay? So the four corners represent S, V, T, and P. And dyan, di ba, yung mga Maxwell's relations natin. Okay, in terms of those four variables only. So how do we use this? So pili ka lang ng any arbitrary starting point. Okay? arbitrary starting point natin, let's say, start tayo dito. Okay, P. Okay, so partial of P, and then pick any direction. Okay, so let's go with this direction muna. So partial of P, tapos next corner, partial of S. Okay, tapos next corner, partial of V. Sorry, V. Okay, so partial of S, partial of P with respect to S at constant V. Okay, so yung third, tapos take out the sign, it's positive V. Okay, this is equal to, next naman, next corner, drop dito ulit, equal to partial of T. Okay, tapos once you got this, babalik ka naman. So partial of V. Okay, holding S constant. Okay, tapos nag-end ka dito, so negative yung sign. Okay, so this is one of Maxwell's relations. And this will also work the opposite way. So gusto natin mag-start tayo kay T. Okay, so partial of T. Tapos unahin natin dito, this way. So partial of T with respect to P. Okay, tapos isa pa, at constant S. And tayo kay S, negative. This is equal to, isa ulit dito, partial of V. Tapos, after partial of V, babalik tayo ngayon to S. O partial of S with respect to constant P. Okay, tapos negative. So, pwede natin cancel ngayon yung negative sign. So, this is another one of Maxwell's relations. Okay, so para madaling tandaan, so 1, 2, 3. Tapos, balik ka, 1, 2. Okay, so yun yung typical. So, go around the square one time, tapos balik ka for 2 more times in any direction. Okay, so you can use this mnemonic to derive, or to not derive, but rather memorize Maxwell's relations. Okay, so ngayon, we have derived these 12 equations. Actually, not 12, that's rather 16 equations. Okay, and you can also memorize this using the mnemonic, the Guggenheim scheme. Okay, so again, we have the 4 Maxwell's relations, you have the 4 fundamental groupings, and you have the 4 fundamental property relations. Okay, so from using these equations along with the mathematical manipulations that we can use, like derivative inversion, chain rule, and triple product rule, we can now form multiple relationships between all other thermodynamic variables, which we'll now use for the next part of this lecture. Okay, so that's it, and thank you for listening.